We're going to do a couple definitions. Remember, anytime you see the word define in the assessment statement or up here in the objective, it's one that you need to memorize. But I don't like that word memorize, so let's learn it instead. So phylogeny is one of the words, and the definition is the evolutionary history of a taxonomic group of organisms. So that means a group of organisms that we've classified in the same group. We can draw some sort of evolutionary relationships based on either physical characteristics or by looking at some molecular similarities or differences in their genetic makeup. So in this little diagram here, they're saying there's an ancestral green algae that our plants came from, right? Our non-vascular plants like moss, and also our vascular plants, ferns, conifers, and angiospermophyta, if you remember, flowering plants from classification. So that's what phylogeny means. So we're just going to look at how they're connected evolutionarily based on features, and we can identify common ancestors. Speaking of common ancestors, the next set of definitions, you may have noticed that it went out of order a little bit. I decided to group these two in the same only because we get the definitions out of the way. So we went from 5.44 to 5.46, and we need to define the word clade and cladistics. So when we're organizing organisms in taxonomic groups, we can do it like you saw in the last one, where you have this kind of branched tree that kind of comes off like this, or you can have these forks. Both are okay. It means the same thing. So a clade is a group of organisms consisting of a common ancestor and all the descendants of that ancestor. What? So let's look at one. So I'm going to look at this blue box here. And in this blue box, we have three ends, right, to our lines. And think of these as different organisms. So maybe at the end of this group, we have organism A. At the end of this one, we have organism B. And up here, we have organism C. Organism A, B, and C, if we're just looking at this blue box, says that they all evolved from that common ancestor. And we're looking at the descendants of that ancestor. So if I'm talking about, hey, are organism A and organism B in the same clade? They are if we're looking at this blue one, because the descendant would be B, right, also connected, and they have a common ancestor down here. I'm going to put some more organisms down on this end. However, if we were comparing this blue clade to this red clade only, we're just looking at these two, organisms A, B, and C are not in the same clade as D and E. These are questions that IB likes to ask. However, if we looked at this gigantic green box that has all of them, all 5 organisms are in the same clade, and the common ancestor for all 5 of them is right here. So at some time, if we were looking at these group of organisms, there was a common ancestor. Some evolved in this direction and became organisms D and E, and evolved in a slightly different way as organisms A, B, and C did. So that's what a clade is, and those are typical questions that IB will ask you about your understanding of them. And cladistics is just the science of naming them. So it's a method of taxonomy by organizing these organisms into clades. There's a term down here that we haven't talked about yet, and it's homologous structures. Homologous characteristics are simply characteristics that have the same structure but are often used for different things. They have a different function. And just a quick example can be, and the real famous one, is I'm drawing, I should do this differently. Let's do it this way. Actually, let's just use the one I have up here. So the famous one is this thing called a pendactyl limb. A pendactyl limb simply means an appendage, like an arm, for example, that has 5 fingers. Pen means 5, dactyl means fingers. So how did that happen? What allowed a whole bunch of organisms to have 5 fingers but use them so differently? So they must have been a common ancestor way back when that had 5 fingers. And through that time, we see organisms still with those 5 fingers, but they're using it for different things. So, for example, a whale, that's my W, a whale has it in its fin, and those 5 fingers are used to help it swim. A bat, also 5 fingers in its wing to help it fly. And then humans, chimps and other apes, they use their 5 fingers for manipulating things. So that would be an example of a homologous characteristic.